All right, ladies and gentlemen. Shoot. All right. I'll still make this work. Hopefully I can get this done before my pencil runs out. So a quadratic equation in one variable is an equation that can be written in the standard form where f of x is equal to 0. That means that it's going to be your x-intercepts and they're going to equal 0. So ax squared plus bx plus c is equal to 0. A root of an equation is a solution of the equation. Again, that's where it's going to either touch or cross the x-axis. All right, a quadratic equation can have 0, 1, or 2 real solutions. Now we're talking about real solutions. I'll show you what happens when we have imaginary solutions. So you can use various methods to solve. The first one is by graphing. So we find the x-intercepts of the related function y is equal to ax squared plus bx plus c. So example 1, solve each equation by graphing. A, x squared plus 3x minus 10 is equal to 0. So plug y is equal to x squared plus 3x minus 10 into your calculator. So if you look here, I did do that. So here is my Desmos calculator. And on the first one there, I did put it as y is equal to x squared plus 3x minus 10. Again, you would have done that also. Okay. Now, I took it so that you can see it. So if I touch it here, there is your calculator. All right. So if you look at it now, again, if you think, remember what I talked about earlier, the negative 10 would be our y-intercept. So as you can tell, and I'm not going to screw it up here, so I'm not going to show you that if I keep going down here, you would see that it would go through the y-intercept at negative 10. But again, if you look here, I told you it's the x-intercepts that we are worried about because those are my roots or my solution. So if we look here, and if I click on it, it tells me one of them is at negative 5 and 0, and the other one is at positive 2 and 0, which is kind of what we would expect. All right, so that's just using the calculator. So again, let me go here and show you one more time. So if I went down by 2's, which I'm going to go, so I'm going to go negative 2, negative 4, negative 6, negative 8, negative 10. So I have one there, and that's my y-intercept. And I just told you that it was at what? 2 was one of my solutions. And my other one was at negative 5. So 1, 2, 3, 4, 5. On these ones here, I went by 1. So that would be 1, 2, and so on. So again, if we draw the picture, and again, I'm sorry that wasn't a great one, but I'm trying to make it so that I get done before I run out. So our x-intercepts here was at 2 and 0, and at negative 5 and 0. So that tells me that my solution is the roots are, so the solution or roots are x is equal to negative 5 and x is equal to 2, which is what we would expect if we would have factored it. All right. The second one, so if I go to the second one here, you can now think about it. First of all, I guess I want to plug it into standard form first. So if I do that, I'm going to take this 12x and I'm going to put it over to the other side. So if I do that, then I'll have 2x squared minus 12x plus 18 is equal to 0. But again, remember, I just told you to set it equal to y. So plug y is equal to 2x squared minus 12x plus 18 is equal to 0 into your calculator. And I did already set that up again here first. So again, let me get rid of that one. And then the second one, I have exactly what I said. So if I do that, as you can see, it just barely touches it. And again, if I was to go up and zoom in or out, I'm not going to right now because I'm in a hurry, you would see that our y-intercept would cross around at plus 18. But as you can tell here, on this one here, we have one real solution, and that one is at 3 and 0. So again, going back to this, all right, I just told you our last one was at 3 and 0. And again, I know it's going to cross over there somewhere. And so on this one here, the solution or root is x is equal to 3. And that's only one. Okay. And if I had one that was 0, all right, it wouldn't cross the x-axis at all. All right. It would be something like up here or down here. Notice that both of those aren't crossing the x-axis. It could be down here, all right, not crossing the x-axis, so there would be no real solution. Okay, so let's go ahead and go to the next one. And it says using square roots, write an equation in the form u squared is equal to d, where u is an algebraic expression. Solve by taking the square root of each side. And the first one, so example 2, solve each equation using the square roots. Now notice on these ones here, notice there's no x term right now. So if there's no x term, we kind of just solve for the way we used to do in Algebra 1. So I'll take and I'll subtract 14. So I'll get 2x squared is equal to 56. Then I'm going to divide through by 2. If I do that, I'll get x squared is equal to 28. And remember, to undo a square, we square root it. Now, since we're in Algebra 2, unless it makes sense, we are going to always make it as plus or minus the square root of the number, 28. So on this one right here, remember, we're going to simplify the radicand. And what that means, ladies and gentlemen, is I'm going to take that plus or minus square root of 28. And remember, I could rewrite that as, well, what are two numbers that when I multiply them, give me the square root, that give me 28? And you would tell me 4 times 7. All right, so if it's 4 times 7, remember now, since I have it as a multiplication there, I can break it up to plus or minus the square root of 4 times the square root of 7, and you know that the square root of 4 is 2. So we would have plus or minus 2 times the square root of 7, and that is your answer. All right, let's try this second one here by doing the same thing. So I'm going to take and I'm going to have 4x squared, and then I'm going to subtract 20 from 16, which will give me negative 4. So again, I'm going to divide through by 4, and I'll get that x squared is equal to negative 1. So think to yourself, is there any time that you can take a number times itself and get a negative number out? And you would say no. So the square of a real number cannot be negative. So there is no real solution. Now notice I put real in capital letters there because we will know, ladies and gentlemen, tomorrow that I will have an answer, but it'll use imaginary numbers. All right, and I'll explain that in tomorrow's lesson. Okay, so let's do one more here. So I have C 3/4 times X plus 1 quantity squared equals 10. So on this one here, we're first going to multiply each side by the reciprocal. And what I mean by the reciprocal is I'm going to take and multiply both sides of this by 4/3, because that gets rid of that fraction, which you guys don't like anyways. All right? So if I do that, then I'll get x plus 1 squared is equal to 40/3. So it's not as nice as you were hoping, but we'll see what happens here in a second. Again, how do I get rid of a square? I square root it. So now I'll have x plus 1 is equal to the square root of 40/3. All of that is under the radical sign right now. And don't forget, we're in algebra 2 now, so we're going to put the plus in the minus. Okay? So now I have x almost by itself. I just have to subtract 1. So when I subtract 1, if I have a square root, what I'm going to do, ladies and gentlemen, is I'm going to put it in front of it. So I'll have -1 plus or minus the square root of 40/3. Okay? So remember what I just showed you here earlier. I can rewrite the top as the square root of 4 times the square root of 10. And the bottom I can write as square root of 3. So I can separate each and every one of them into their own square root. All right? And if we work that out again, same kind of thing, x is equal to -1 plus or minus, well, square root of 4 you just told me was 2. Square root of 10 has to stay the same. And on the bottom we'll have the square root of 3. But remember, and this is from Algebra 1, and I did look at your textbook to see that you do have this. So remember, you can't have a radical in the denominator. So multiply by the square root of 3 over the square root of 3. All right, so if I do that, I'm going to take x is equal to -1. I don't have to worry about multiplying that part by the square root of 3/3 because that has nothing to do with getting rid of the radical. But on this one right here, I will have to. So I'll multiply it by the square root of 3 over the square root of 3. So, excuse me, remember from earlier, if I have 2 underneath that are the same number, I can just write it as a number. So think about it. If I was to multiply those together, I'd have 3 times 3, which is 9, and the square root of 9 is 3. So I always say if you are getting rid of it, that's going to be your answer right there. But now I have a 3 on the top. So let me go ahead and say 1 plus or minus. I'll keep the 2 there. But you now see that I just have a 3 on the bottom. On the top, if I put the 3 It's prime. If I did 10, it would break up to 5 and 2, which are also prime. So basically, if I have stuff that's not going to simplify the top there, and it shouldn't if we did this correctly, then I'm going to have to bring those two together. And what is 10 times 3? It's the square root of 30. So there is our answer for that one. Okay. And then the last one we have is by factoring. By factoring, we're going to write the polynomial equation in factored form and solve using the zero product property. Remember, with the zero product property, you're going to say that a times b is equal to 0. If that's the case, then we know that one of them has to be 0. Either a has to be 0, because 0 times anything is 0, or b has to be equal to 0. So anything times 0 is equal to 0. All right? So let's go ahead and do these next examples. So solve x squared plus 2x equals 48 by factoring. Remember, you're going to rewrite that as x squared plus 2x minus 48 is equal to 0. So if you look at that one there, ladies and gentlemen, if I do that, I can say that, let's see, if I factor it, let's remember, if I have a coefficient of 1 in front of the x, think of doing it this way. So I'm going to have an x here and I'm going to have an x here. I look at this sign here. If that one is negative, one's going to be positive and one's going to be negative. All right? So one's going to be positive and one's going to be negative. And remember, that's telling us it's equals to 0. So now you have to think to yourself, what are factors of 48? When I multiply them, will give me a plus 2. Well, 48 would be 8 times 6. All right. And so if you think about that, that gives me plus 8x. That gives me minus 6x, which gives me plus 2, which is what I need. If this one here was positive, then I would tell you to look at this one here. And if it's positive, both of them will be positive. If that one's negative, they'll both be negative. All right, that'll help you with your homework. So, knowing what I just said, by the zero product property, we know that x plus 8 is equal to 0, or x minus 6 is equal to 0. Now just solve those two for x. So I'll get x is equal to negative 8, or x is equal to positive 6. Those are my roots. Finally, the answers above could also be called zeros of the function. So zeros, roots, solution, all mean the same thing. Okay? Because a zero of a function, f, is an x value for which f of x is equal to 0. So, example 4, find the zeros of f of x is equal to 4x squared minus 13x plus 3. So I'm going to show you the diamond and box method. All right, so what I would do here, ladies and gentlemen, is again, I'm going to set it equal to 0. Now take the first term and the last term and multiply them and put it in the top. So 4x squared times 3 will be 12x squared. Take the middle term, in this case 13x, and put it down below. And that is a negative 13x. So now, think to yourself, what are two numbers, when I multiply them, give me 12x squared, yet when I add them, give me negative 13x. All right, so if I give you some wait time there. So if we took negative 12x and negative 1x, that would give us exactly what we need. All right? So now I'm going to take that and I'm going to put it in a box. Okay, I want to make sure I give myself enough room there. So in the diagonal of one of the boxes, you're going to put the first term and you're going to put the last term. And let me write those a little better. So 4x squared, and then I'm going to have plus 3. In the other diagonal, you're going to take the 2 that you just got and put them in the other diagonal. And it doesn't matter which way you do it, ladies and gentlemen. I could have put the 4x squared on the top of this box up here, but I chose not to. Again, just as long as they're in diagonals. So I'm going to put negative 12x here. I remember a lot of times I would just call this negative x, but I left the coefficient there for you. All right, so now I'm just going to factor those boxes. All right, so I'm going to take these two here. So what can I factor out? If I go this way here, I can factor out a 4 and an x. All right, because there's a 4 and negative 12, and there's an x. So now I'm just going to multiply to get what's in that box. 4x times what gives you 4x squared? And you would tell me it's an x. 4x times what gives you negative 12x? And you would tell me that is a negative 3. All right. Then I have to look at the other way here. So I took care of that one there. Now look at this one this way here. So I'm looking at this one here. X times what gives you negative 1x? And you would tell me minus 1. And then as a check, does negative 3 times negative 1 give you a positive 3? And you should be able to tell me yes. All right, so knowing that, we could then say that our factors are 4x minus 1 and x minus 3. And remember, we're going to use the zero product property, so we're going to say that that is equal to 0 or x minus 3 is equal to 0. And again, just solve. So on this one here, I can take 4x, bring that one over, and now I can divide by 4, and I'll get x is equal to 1/4. On this one here, again, that doesn't look very good, does it? All right, so let me fix that here real quick. Or okay, or x minus 3 is equal to 0, and if I solve that one, I'll get x is equal to 3. So there are two solutions. Now on this one right here, I don't want you guys to think that you have to do that for every single one that doesn't have a coefficient of 1 in front. You can also use other things that might help you. So if I'm going to look at this, look at something you can factor out. Always look for something you can factor out. If I look at that, I can see that I can factor out a 2. If I factor out a 2, then I'm going to have x squared plus 2x minus 3 is equal to 0. If I divide both sides by 2, that's going to go away. And what is 0 divided by 2? That is 0. So then I will have x squared plus 2x minus 3 is equal to 0. Again, what I just showed you up above, since I have a coefficient of 1 there, I can put an x here and an x here. I look at this sign here, again, it's negative, so I know I have to have one that's positive and one that's negative. And what are factors of 3? Well, it's just 3 and 1. So where are you going to place it so that you get a positive 2x? And you would say, I'm going to put the 3 here. I'm going to put the 1 there. Put it equal to 0. Again, by the zero product property, we know that x plus 3 is equal to 0, or x minus 1 is equal to 0. Again, solve those for x. X is equal to negative 3, or x is equal to 1. There you go. Hope that helped you. Thank you.